Here, the steel material is processed plastically at very high temperatures. Rotating rolls reduce the thickness of the material and produce long strips that can be used for manufacturing products such as steel plates. We will be going through the various stages of the hot rolling process. Each stage requires knowledge and experience to ensure a high-quality product. The material is heated in the reheating furnace, rolled in the roughing mill, coil boxed, roll in a finishing mill, cooled and coiled. Before the slab can be processed, it must be heated. The slab is continuously cast and has the dimensions required for the final product of a correct weight, width, and thickness. These furnaces heat the material to about 1200 degrees centigrade. 2 walking beam furnaces feed the material through the oven. The heating is especially important as it affects the properties of the material. If the material is not sufficiently heated, incorrect material properties will arise. This is due to carbides and nitrates failing to dissolve. During the heating process and the transport to the roughing mill, the hot material reacts to the oxygen in the air, and a mill scale consisting of oxide is formed on the surface. If the oxide layer remains on the material during rolling, the layer risks being rolled into the steel material, adversely affecting the surface quality of the final product. The material must undergo a mill scale cleansing before rolling. In order to cleanse the surface, water is sprayed at high pressure, 160 bar. After the material has undergone a surface cleansing, it's sent to the roughing mill. Here, the material is rolled from its original thickness of 22 centimeters down to about 3 centimeters. This is a very significant reduction. At this roughing mill, a powerful 4-high rolling mill is used. That is, 2 backup rolls and 2 smaller working rolls. The backup rolls are often cast steel rolls. The working rolls must have very smooth surfaces and tolerate high temperatures and wear, as they are in direct contact with the material. This particular material is rolled with 5 passes, where 1 pass means that the material passes through the rolls once. The material is surface cleansed several times during the roughing mill process to remove any new traces of mill scale. In order to control the width of the material, vertical rolls are used. The material is now called transfer bars. After the roughing mill, the transfer bar is rolled up in a coil box. The coil box's primary purpose is to save space, but when inside the coil box, a temperature equalization also occurs. The temperature difference between the ends of the material is minimized as the transfer bar is coiled together. When the transfer bar is removed from the coil box, it has a temperature of about 1050 degrees centigrade. The ends of the transfer bar are cut off and the bar undergoes further mill scale removal. After this, it's time for the next stage, the finishing mill. This mill consists of 6 stands in the shape of 4 high rolling mills. Here, the transfer bars, now called strips, are rolled into a thickness of between 16 and 1.8 millimeters. Between the rolls we see an uplooper, which measures and controls, amongst other things, the line speed and the strip tension. The swinging motion that can be observed is when the uplooper is adjusting itself. in order to control the profile and the flatness of the strips. The working rolls are horizontally adjustable. The first stands control the profile, and in the later stands the flatness is controlled. It's very important to have a correct strip profile and flatness before any post-processing starts. The cooling rate is adapted to each strip to produce the appropriate microstructure and material properties of the end product. When the strip has passed through the cooling section, it's coiled in. The temperature during coiling varies between 150 and 750 degrees centigrade, depending on the properties assigned to the material. After coiling and the subsequent cooling, the strip can be sold directly to the customer or undergo additional processing stages, for instance, cold rolling.
Hello guys, Assalamualaikum warahmatullahi wabarakatuh. We will describe of the rolling process.
First question come in our mind, what is rolling process? Rolling process is a metal forming process in which stock of material is passed between one or more pairs of roller produce and maintain uniform thickness. Rolling process is classified as hot rolling and cold rolling. Now, what is hot rolling? Hot rolling process in which metal to be passed between the rollers is heated above its recrystallization temperature. Then the process is known as hot rolling, and obviously if the temperature of metal to be passed between the rollers is less than the recrystallization temperature, then the process is known cold rolling. Following are the different types of configuration used in rolling mills. First, 2 high rolling mills. Second, 3 high rolling mill. Third, 4 high rolling mill. Then cluster rolling mill, and last in tandem rolling mill.
Let us discuss all the rolling mills one by one. First is 2 high rolling mill. This is the simplest type of rolling mill setup in which to roll or used. The distance between two rolls can be adjusted according to the metal thickness. The lower roll is fixed, whereas a pair roller has vertical motion to address the distance to rolls. Both the rolls have opposite direction of rotation. It means if a upper roll rotates in anti-clockwise direction, then lower roll rotates in clockwise direction. This type of rolling mill known as non-reversing of rolling mill. Further, we'll discuss about reversing rolling mill and non-reversing rolling mill. In this case, the stock or ingot is fed to the rolling mill from the left side. The two rollers will exert a large amount of pressure on the stock and force out to the right side, which result in decrease in the thickness of rotation of two rolls. We are unable to fit in cord from right side, so it is known as non-reversing rolling B.
Feeding of metal stock from right side is also possible provided that there should be arrangement of changing the direction of motion of the ruler. In reversing mill, we can fill metal stock from both sides. The reversing mill are used to increase the productivity. Next type of rolling mill is free height rolling mill. In this type of rolling mill, 3 rollers are used one over the other in vertical line. We can pass the ingot between first 2 rollers and then last 2 rollers. Please remember, direction of rotation of first and last roller is always same in this type of rolling mill. This type of arrangement has higher rate of rotation than the 2 high rolling mill because we can pass 2 metal stock at a time. For high rolling mill, use this setup is very much similar to 2 high rolling mill. But in this mill, instead of 2 rollers, 4 rollers are placed in a vertical line. But the size of all rollers is not same. The 2 rollers which come in contact between the metal stock have the same size and the other 2 have same size. The big rollers are used for backup purpose only. Small roller will expel pressure on the metal stock, or thickness of material will get decreased. Size of degradement is more in this case as compared to the other 2 causes we have discussed above, and especially this rolling mill is used in case of rolling of hard material. Next is cluster. Rolling mill in this type of rolling mill, or in some cases their backup rollers, are used to reduce the thickness of hard material. Following point is very important about rolling mill. If we talk about the material, its volume remain constant in all the cases, but only change in shape and size take place. We can see in the picture length of metal stock is less before passing to the roller. But after rolling operation, length increase and thickness of ingot decrease, or in other words, length is inversely proportional to thickness of material. And the last is tandem rolling pin. In this type of rolling mill, metal stock is constantly passing through the different parts of roller, so that we can obtain the degree shape and size of the component in one pass only.